Okay, so now let's have a look at these worksheet problems here. In problem number 4, you're asked to find the percent by mass of each element in this compound, HC6H7O6. So really this is just a matter of determining the individual masses of each element, so you can do that by multiplying the molar mass of each element by the number of atoms of each element. So for hydrogen, right, a molar mass is 1.008 grams per mole, and we can multiply that by there being 8 moles of hydrogen in 1 mole of the compound. I'll give you a mass of hydrogen. In the denominator, we've got the total molar mass of this compound. We can do that for each of these elements here, and that'll give us the percent by mass of H, C, and O. And again, if you can't remember the formula for percent by mass, I'll write it out again. So percent by mass is equal to the mass of the part, in this case the part is the element, over the mass of the whole, and the whole is the compound here, times 100%. But that's going to come in handy whenever we get to work with percent by mass either in this problem set or in the future. Number 5 here is a two-part problem. The first part, you're given percent by masses of carbon, hydrogen, oxygen, and nitrogen, and you're asked to find the empirical formula of a substance, and in part B, you're given the molar mass of that substance, so that's the molecular molar mass, and you're asked to determine the molecular formula for it. So again, same procedure every time you want to figure empirical formula, starting with percent by mass. Assume you have 100 grams total. So in this case, we assume we have 100 grams, we've got 59 grams of carbon, 7.1 grams of hydrogen, 26.2 grams of oxygen, and 7.7 grams of nitrogen. Again, basically all you do is you switch out percent for grams here. Our next step is to figure out how many moles of each element you have, and you do that by dividing by the molar mass. And that gives us the values that you see here for moles. You can then identify which moles, or which number of moles, is the lowest. In this case, nitrogen has the lowest number of moles. You can divide each number of moles by that lowest number, 0.55, and doing so should give you numbers either close to a whole number or close to a half number. Right? If it's close to a whole number, you round to that whole number. If it's close to a half number, you multiply everything by 2. We don't have to worry about halves here because all of our resulting numbers are close to a whole number, like 9, 13, 3, and 1. You then use these whole numbers as the subscripts in your chemical formula. So our empirical formula for this compound is C9H13O3N. Once you determine your empirical formula, you need to figure out the empirical mass of that formula to determine the molecular formula. So you can do that again by adding up the molar mass of each element times the number of atoms of each element. So we've got 9 carbons, each of them has a molar mass of 12.011 grams. We can do something similar with the hydrogens, oxygens, and nitrogens. Right, that yields a total molar mass of around 183 grams. Or sorry, an empirical molar mass of around 183 grams. To determine the molecular formula, what you do is you take the molar mass of the molecular formula, so we're given that, it's 180 grams. You divide it by the molar mass of the empirical formula to get a whole number. It should be something close to a whole number. Again, you can round if it's pretty close to it. After you get that whole number, you multiply all of the subscripts in your empirical formula by that number to get your molecular formula. In this case, our whole number is 1, so we don't really have to do anything here. Our empirical formula and our molecular formula are one and the same. This last worksheet problem, number 6, is kind of tricky, and to be honest, there's a bunch of different ways you can solve this one. I'm going to go over one possible way here. So what you're told is you have this oxybromate compound, and it's got a chemical formula of KBrOx, where X is some whole number. And what you want to do is you want to figure out what that whole number is. The only other information you're given here is that it's got 52.92% by mass of bromine. So the way I figured this out is by the following procedure. So I went from percent by mass of bromine to grams of bromine, and from there to moles. So once you determine the number of moles of bromine, You know from this chemical formula that there's going to be an equal number of moles of potassium. The subscripts for both K and Br are 1. We don't write 1, but the subscripts are one and the same. So you should have the same number of moles of K and Br. Once you get your number of moles of K, again using that number of moles of bromine, you can backtrack, and backtrack from there to grams. If you get grams, that's the same, we're assuming we have 100 grams total, that gives us percent by mass of potassium. Okay, all of our percent by masses need to add up to 100% here. So we can then figure out the percent by mass of oxygen by subtracting our other two numbers, our percent by mass of potassium, 25.89, and our percent by mass of bromine, 52.92, from 100. That gives us 21.19% oxygen. Okay, from there, we have the percent by masses of our three elements in our compound. And we've solved problems like this before, where you're starting with percent by mass and you want to figure out the empirical formula for the compound. You get percent by mass, you assume you have 100 grams, you use that to get the grams of each element, you go from grams to moles, and then you figure out which number of moles is the smallest. In this case, we have 2 with 0.66 and 1 with 1.32. You divide all the numbers of moles by that smallest number to get something that hopefully is close to whole numbers. So in this case, the whole numbers are 1 for K, 1 for Br, and 2 for O. These are the subscripts in our compound. So that gives us the formula of KBrO2 for our oxybromate compound.